Welcome to episode 13 of live.withcode.uk. Well done to everyone who took part in last week's activity where we created a login system with password hashes. So instead of storing a password in plain text in our code, we stored the hash of the password, which means it's harder for people to gain unauthorized access. So particular well done to Reese from All Saints, your last week's competition winner. I'll confirm permission to send out your certificate and prize as soon as I can. And we're going to continue with the theme of encoding and encryption this week to create a Caesar Cipher solver. So we have a Caesar Cipher encrypted message, and then we want to write a program that will read this text from a file and decrypt it, take it from a ciphertext that we can't understand into a plain text that we can understand. So Caesar ciphers are not particularly secure. They date back to Roman times before computers. Nowadays they're far too easy to solve. But the idea is if we have a Caesar cipher that we want to solve, we take each character in turn, so we'll take the O here, and we've got two rings on a Caesar cipher. We look up the character on the outer ring, so we find an O, and we read off the character on the inner ring. So O here is going to become W, and then we repeat that algorithm, those step-by-step instructions. So we find W on the outer ring, and we read off an E, and then we find two Ds, so we read off on the outer ring for the ciphertext, the encrypted text, and we read off on the inner ring, the plain text, the one that we can understand, and you can see how each letter is shifted across in the alphabet. So we've got well done, you have solved the puzzle, blah, 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 blah. So that's how they work. The algorithm's nice and simple to code. I'll show you what the program's going to do, and then we'll code it together. First of all, it asks you which file we want to read from, and the aim of today's session, as well as encoding and encryption, is to talk about exception handling, so to make your code fail gracefully. So if we try and open a file that doesn't exist, we want a nice error message rather than the program crashing. But if the file does exist, it should ask us how far to shift across. Again, if we type in something it's not expecting, we want it to be able to continue to ask until it gets something that it can use, and then it will display the right answer. So let's get started. We're not going to use any modules today. We're just going to write an introduction message for a Caesar cipher. Oops. And remember, it's live coding, so you'll see all the mistakes that I make, but the point of watching these videos is to try and understand the logic behind the code. And remember, the links to all of the links to all the activities, the online learning, remote learning resources are on live.withcode.uk or in the description underneath this video if you're watching on YouTube. So first of all, we want to be asked which file to open. So we ask the question with input. I'm just going to say file name, and you always have to listen to the answer and store that. So we'll say file name is equal to. We can type in whatever we like here because it doesn't actually open a file yet. So now we want to open that file, and we want to, there's two ways of doing this. We could say f equals open and then remember to do f.close afterwards, or I prefer to do with open as f and then use the file whilst it's indented, and then as soon as you stop indenting or the program finishes, it automatically closes it for you. So once we've opened it, we can do f.read, and then let's just display the contents of the file. So if we open a file that does exist, you can see the contents. If you open a file that doesn't exist, it crashes. Now this is a runtime error, and the extension activities in the links underneath this video take you to some runtime error activities. A runtime error means the program does run because lines 1 and 2 have run, but then it tries to do something impossible, like reading a file that doesn't exist, and then it crashes. So to cope with that, we just need to tell Python to try and keep on trying. But if something goes horribly wrong, if it comes across a runtime error, you just tell Python what to do. So try if it works, but if an exception is thrown, if something goes wrong, you can put your own error message in here, could not open, and then we can even tell Python which file it couldn't open, which is file name, this variable here. There we go, so that's better. Next, we want to ask the user the Caesar shift. So for this example, and you can put your own Caesar Cipher encrypted messages in here, this is shifted across by 8 characters. Remember the Caesar Cipher wheel. A has been shifted across 1, 2, 3, 4, 5, 6, 7, 8 places. So let's say shift equals input and then ask for the Caesar shift. And then we want to keep going until we get a valid answer. Now, if we ask for a number, we have to convert the string that we get from input into an integer, so we can store that numeric value in shift, which means we might get another runtime error. If we say what the file is, but we type in anything that isn't a number, we're going to get another runtime error. So we're going to do exactly the same. We'll say try, and then if that fails, accept, and then print, please enter a number. Now this is going to be better. I'm going to put any file name in here for now. Caesar shift. If I type in something, we get an error message, but I'd like it to keep looping round until we get a valid answer. So do some validation here. So let's say valid is equal to false. We haven't got a valid number yet. And then we can keep looping. So we'll say while valid or while not valid. And then everything that's indented, I'm going to press tab to indent these across. And then if we do get a valid number, that means this line of code has run without crashing. So this line of code will move on and run. We can say valid equals true. So what happens now, I'm just going to put anything in here for now. I put an invalid answer in and it keeps asking until we put a number in, and then it checks the file name and it's failed here as well. Okay. So for now, I'm going to comment all of this out because I don't want to have to type it in each time that we test it. And I'm just going to put file name is equal to secret.txt and shift is equal to 8. So we can test and see if it works. So at the moment, we're just seeing the message as it is in the file. Nothing clever's happening with it yet. So rather than displaying it, let's store it in a variable so we can process it. So it's going to be ciphertext, the contents of the thing we want to decrypt is equal to f.read. And we want to work out what the plain text is. And for now, we're going to have an empty string and we'll add to that string a character at a time. So to get a character at a time, we need to for character in ciphertext. So each character in this ciphertext here. Help. First of all, we need to know what value that letter has, and we're going to use ASCII, American Standard Code for Information Interchange, which just means each letter in the alphabet has a code. So the decimal of capital A is 65, and then 66 for capital B, down to 90 for capital Z. Now, lowercase letters have different values, and punctuation and everything like that are all separate, but we're just going to use capital letters. So in order to get the ASCII value, we use the built-in function in Python, ord. So we'll give a parameter of character and we'll work out the ASCII value in here. So let's just print that for now. So we can see the ASCII value of each character. Let's test it and see. So O is the first one. So if we find a capital O in ASCII, it should be 79. Yeah, great, it's worked. Why did we do that? Well, so that we can add a number onto it. So if we say new ASCII, the new ASCII value is going to be the old one plus the shift. So we can add or take away a value to each ASCII value. And then we want to convert back from ASCII to the actual character. And we use CHR, the built-in function CHR, short for character in Python. So the new ASCII value has got the Caesar shift added on. We pass the new ASCII value as a parameter to CHR, the built-in function. And we want to add that on, concatenate it to our plain text string. So at the moment it's setting it. We want to add each character on separately. Okay, so it doesn't look like anything's happening, but it opens the file, it loops through each character, and then after the for loop is finished, so lined up with for here, we're going to print plain text to see what happens. So this has mostly worked. You can see it should say, well done, you have solved the puzzle, but some things have gone weird. Like this character here should be an E. Well, what's happened is that the W has been shifted across by 8 characters and it's gone off the edge of the alphabet. It's kind of gone down to here somewhere. So we're just going to need to put some extra logic in to say if the new ASCII value is greater than 90 for a capital Z, then we want to take off 26 because there's 26 characters in the alphabet. New ASCII minus equals, which means decrease by 26. And similarly, if the new ASCII value is less than, so if we're shifting backwards, go in the opposite direction, and it goes less than 65 for a capital A, if it goes less than 65, then we'll just add on 26, so it wraps back round and goes from Z. So I'll just put some comments on here, wrap around to A if the letter goes past Z. And I always like to leave a blank line above the comment so that it's really clear that the comment refers to the line underneath. And then the same here, warp wrap around to Z if the letter goes past A. Okay, so now we've solved the puzzle here. Now, there are a few problems, as in if what you load in has some punctuation or spaces or anything like that, when we try and run it, we get some weird characters in here because the space is ASCII Caesar shifted as well. So I'm just going to put some logic in here that says if the character is alphabetical, so if it's an alpha character, and only then do we shift it across and add it to the plain text. So if it's not a letter, it just ignores it. And the reason we're doing that is because if you had spaces in here, it would make it so much easier to solve and hack into your Caesar Cipher code. Okay. So the last thing that we're going to do is get rid of these and put our logic back in to ask the user what file they want to load. So let's try with a file that doesn't exist. Now it would be nice if we got an instant feedback. You know, I know this file doesn't exist, but it doesn't crash until later on. So the bit that asks for the Caesar shift, I'm going to move that after we've tried to read from the file. So we get the plain text. I'm going to do that in here. Sort the indentation out. Here we go. So we try and open a file, and as soon as we type something that doesn't exist, we get the error message. If we type something that does exist, and we put an invalid value in here, then our exception handling is dealt with that. We put in the correct one, and it solves the puzzle. Notice here we've got nested try and except. So if this fails, then we get an error message to say, please enter a number. But if something fails, we get a runtime error outside of these two lines. Then it will go back to this try and except handler, this exception handler in here. So there are a couple of challenges that you can work through. So you can have access to the code. I think it's linked to in the description on YouTube, or they're all available on live.withcode.uk. Number one, write your own secret message in a new file. So I've got secret.txt. You can make your own. Number two, make your program keep all spaces and punctuation. So get rid of this logic here, and perhaps just always put a space in if there is one in the encrypted file. Or you could, instead of asking the user for the Caesar shift, you could put a loop in so it goes through all 26 possible shift values and displays them all, so you can quickly hack into a Caesar Cipher encrypted file and see what the actual result is. So remember, the remote learning resources are on live.with.code.uk. Do join in with the competitions. If your school is registered, then you can win the prize next week. And it looks like the most popular thing for next week is going to be robotics with the Raspberry Pi. So do vote for that if that's what you want, or suggest an alternative if you want to do something else. Thanks for listening. All the very best. Bye-bye.